What is an arcade game without controller support? So I'm going to test a lot of different game controllers. Across Windows, Linux, which also includes the Steam Deck and macOS. This will guide you what works and what doesn't. To test all this compatibility, I'm going to use my custom C# game engine. It was a pain in the ass, but at least you don't have to. After testing, I will also talk more in depth how I implemented it. No further ado, let's do this. Alright, but how are we going to test this? I made a very simplistic Raylib game that shows the buttons that are pressed. With 2 buttons, we can also enable the rumble. I can already tell, based on my research, there will be some interesting results for this. Yes, you talked about the software, but it needs to run on something as well. And yes, you are correct. We have 5 machines to test. Which ones? We're going to test on the Xbox 360, the Xbox One, the PlayStation 3, the PlayStation 4 and a cheap Super Nintendo USB controller. And an 8BitDo controller. And this all on the MacBook M4 Pro, Windows 11 gaming PC and a mini PC with Ubuntu. But I also have an arcade cabinet with an hit arcade buttons. This one runs on Windows 10. Then, as last, we're going to test the Steam Deck. And you think, oh cool, with Raylib? Yes, but not only Raylib. What if I told you my controller implementation can support Raylib backend, but also the SDL2 controller input? Alright, let's test this. Let's first test Windows. Let's see what it will be. This is kind of interesting. The PlayStation 3 doesn't work directly out of the box in Windows for some reason. Alright, I tested all the controllers. There are a few interesting things, is that I thought that in Raylib the rumble will work in Windows. And also there were a few interesting things, is that the 8BitDo and the cheap Super Nintendo controller, the A and B buttons were reversed. Alright, let's continue with the on the Mac. Then let's test everything. This is interesting. When I hooking up the Xbox 360, it gets requested twice on the Mac for some strange reason. This is interesting. On the Mac, on Windows, this button didn't work, but on Mac it does. And it is requested as a middle button. Also, it's a bit annoying, because if you press it, then you always get this annoying pop-up. Alright, test results are in for macOS. The Super Nintendo controller didn't work in Ray. PlayStation 3 controller surprisingly got detected. It works, but no triggering of the buttons. For SDL, there are also some surprising things, is that the PlayStation 3 got triggered, but the whole button layout was just completely messed up. Alright, let's go to Ubuntu. The mini PC is now connected with Ubuntu. Let's test. Interesting. This controller also detects the left bumper and the right bumper for some reason. This is funny. On Linux, the trackpad gets registered as a mouse. And it also clicks. So you can also use it as a mouse. Alright. Results for Linux, and in this case the Ubuntu. The 8-bit though, there are a few surprising things. That the 8-bit though for some reason fails. Small remark though is that I am just testing it as is, so I am not going to do some special tricks or make some special adjustments. And another interesting situation was that in SDL, in macOS and in Windows it did work, but here the Rumble didn't work for on all of them. Could be a rights issue, which I also have read about. So out of the box there is no Rumble. Alright, then we're going to test the next one, which is the Steam Deck. Steam Deck is hooked up. I'm ready to launch the application right away. Okay, Steam Deck test is done. Keep in mind I'm testing this in desktop mode, but the surprising thing is that both in Ray and in SDL the Rumble didn't work. To correctly implement the Steam Deck, you probably need to use the Steam API. Alright, I promised the arcade cabinet. This one has dual controllers. Let's see how it's going to behave. Tested everything with Raylib. Didn't respond at all, surprisingly. But it did detect the correct name of the device. In SDL, it just worked. Let's do the final recap for the testing. You can see some different behavior between Raylib and SDL. For some reason, Rumble didn't work at all on all the platforms with Raylib. The input used GLFW. They said they use X input for Rumble, which should normally work in Windows, but for some reason it was keep mentioning it's not supported on the platform. It didn't work on Mac, it didn't work on Windows, it didn't work on macOS. So the question is, which platform does it support? Maybe you know, let me know. Maybe I'm using a wrong version of the Raylib binaries, but it's the one that is coming out of the box. But now you can see why it's important to support multiple backends. Because if you want to have cross-platform Rumble support, then in my opinion, until what I've seen from the testing, SDL is the better choice. But now comes the question, but why support Raylib at all? Well, I have a few reasons. If you don't need Rumble and you want to keep it lightweight, then it gives you that option. And here comes the other one. It does not work. For now. But the Raylib development is quite active. So hopefully in the future it will be addressed. Then we don't need really code changes. The system is already prepped. Also, all the test results will be committed in my Git repository. I will put a link in the description. Alright, but how does it work in my custom game engine? Let's take a deep dive, and at the end, we will implement it in my Pac-Man game. Alright, we have now tested everything, but how does it work behind the scenes, or in the guts? In my opinion, for proper game development, first of all, you need I prefer that we have a list of buttons that you want to use inside your game, which is basically those enums like here for up, down, left, right, start an action for the Pac-Man game, which is in here. And if I'm pressing enter now, because it's using the keyboard, then it knows that you are using the action. The way that it knows is that because here it will ask in the player input router if a specific button has a specific state. And the role of the player input router is that one is actually knowing which implementation is being used for a specific device, which can be indeed the keyboard or the Arduino-based input or the controller input. And those controller input manager or the Arduino input mapper or the generic input mapper is then asking on specific I-input implementation the real specific state, because in those are the actual bindings for the hardware. Just as a nice example, if I am opening up this is one for the controller, and here we are creating all kinds of generic input, which is basically a base input with an I input. And this one is just asking, all right, for example, for the D-pad down, is the gamepad down? Or then it's a 1 or a 0, because if you look at the implementation of the I input, there you go, then you can see we have enabled, down, up, is pressed. And the interesting one with is pressed is that that's only get true on one update cycle. And we have then the normalized value. You're asking why we also have the normalized value, because keyboard and the arcade controllers and such a thing, they are always just 0 and 1. But for a controller, it's a bit different, because we have also the analog sticks, which can be between 0 and 1. And for the Joy-Cons, it can be -1 and 1. Because we have a differentiation between the X and the I. This is basically how in general, how the input mapper is working. And the only thing that you need to do is in here, for example, with Pac-Man, we have the input mapper for the hardware, the Arduino mapper. We are saying, all right, the game input up needs to be bind to controller input enum up, and the same story is for the fallback. With here we are saying the game input up is up, but for player 2 we have up and W. And I forgot to mention we do also, it's not. Because like I already mentioned, the play input router making a differentiation between the specific players based on a specific number, which the default player will always be player 1, but the second player will be 2, and so on. So that's basically how the input router is working. But yeah, this video is mostly about the controllers, right? So now we have a general understanding how the input mapper is working. How does the system work with the different controllers? If you look at my example for the controller, if you look here, then as I'm going to run the controller test, then you see that the controller is working. This is the tool that I use for making the test results. But in the overview, you have already seen that we have the controller input mapper. But the controller input mapper is not the one that doesn't know which specific hardware you use. There is an additional layer added to it. And the way that it works is that when you are creating the controller input mapper, you also need to specify the controller device manager. And this is the one that can be, for example, for now we have support for the VDIP controller device manager, or we have the SDL control device manager. And then this is the only thing that you need to do to specify which one you want to use, everything down below is exactly the same, because they are just the same interfaces with the same abstractions. And the way that I have implemented it is that we have the control manager, which basically is asking for the devices, how many devices are currently there, is a device assigned. This is not about the player, it's just about the device itself. And then we have also one for the devices, for the controller itself. So there will be for each controller will be an implementation added will an instance be created for this. And in here, you can see that it can asking for a state, and you can do the run ball and also the controller type. The controller type is also kind of interesting, because the reason why I added this part as well, and which I think is really important, is because when you are when you are making a game and you want to show someone that need to press a specific button, well, the most important thing that you need to do is you need to ask the you want to show, if it's an Xbox controller, then you want to show the A, but round A button, right? But for the PlayStation controller, you want to show the X and not the A, which can be confusing. So that way you can then easy implement, and in the future I'm going to extend this, that in the end in implementation you can see that if it's a keyboard, or if it's a mouse with specific or if it's the Arduino controller, then making an easy utility that you can easily say, I want for this button a specific sprite. So that's the use case behind it. For the to assign the buttons, I made a large enum, which is for all the buttons on the controller. And on top of it, I also added just button 1 to 10, which is making sure that if you are using some exotic controllers like the one in the arcade cabinet, then those enums doesn't make sense. But then button 1 to 10 makes sense. But in most cases, if you just want to roll out on for people that just want to play it on their PC or Mac or whatever, then they most of the time have just a normal controller, and then those buttons make sense. But funny enough, most of the time the button 1 and the A-cross will be mapped as the same. Now you have a general understanding about how this part is working. Let's do a showcase how we can convert Pac-Man to the actual control implementation. And normally when we are doing a test development, we do have the fallback implementation, which is in here, you see. So we're not going to use this one. There you go. I'm just going to borrow this part. So that makes lives a bit easier. Then let's make sure that we have correct references. And then we need to assign the game input as well in here, so it knows which game-related inputs we want to use. And of course, we also we will create a mapper. No worries, but we will create because this is a 2-player game, and otherwise the router is going to whine about, I don't know what to do with player 2, because it's a spectrum mapping for player 2. So we're going to make the mapper, which is the controller input mapper with, of course, yet again the game input. Of course, I need to initiate it with and I want to use the SDL controller device manager. Which, by the way, a small note: if I am going here and if I'm going here, this is a separate C# project. The reason why I decided to make it a separate C# project is that if you only want to use the Raylib implementation, then you don't have to load in this C# project, and then you also don't get all the SDL binaries and such a thing. So it's completely up to you how you want to use it. Now we have the controller input mapper and the SDL control device manager. The reason that I want to use now the SDL control device manager is because I also want to implement a Rumble, which, based on the testing that we have seen, does it work in Raylib. Then hopefully the PlayStation controller will then also rumble. It makes it amazing. All right. Let's first assign all the buttons. The start will be A or cross, and let's do the action will be the B or circle. By the way, you can see that I make the enum so that you know it's for the PlayStation controller and also for the normal controllers that is using A or B. It's actually funny that the PlayStation is the only one that is not using A, B, X and I. This is interesting, but doesn't matter. D-pad left. Negate. It's down. Down. Okay, up. And we want to use the left, the up, and the down. No, and right. Yes, my head is always one big mess. That's also the reason why sometimes I am rumbling a bit, because sometimes when I'm speaking, my head cannot. My voice cannot follow my head, if it does make sense, but doesn't matter. Mapper, and we also want to make sure that the D-pad is true, because in Pac-Man, if we go to the game object for the Pac-Man itself, if we want to know the direction of this specific game, it's asking for the get access for number 1, and normally the D-pad is not an access, but so in this case we want to use the D-pad for Pac-Man. All right, this should be it for everything to make the basic controller work. Let's see if it does work, if I am starting the correct application, of course. Pac-Man with keyboard. It's a lie now because it's a controller, but it's just a proof of concept. All right. Let's see. Does it? It doesn't work. You know what? I also forgotten a very important part. For device. Because the reason that it didn't work, and let me show it to you, I completely forgot to implement it, is that you also need to assign the specific device to a specific player. Assign device, so it's here, and it will always start with device 1, and for the other one it's 2 and 1. So now, if I'm now going to run it, you will see, boom, It works! Finally! This is amazing. Then let's see if we can also let Pac-Man run. Otherwise the game will be a bit hard to play. We can go left, we can go right, we can go down, we can up, down, up. Yes, everything is working as expected. Amazing. But now comes the part is that we also want to have things like rumble support, which is not that hard. So what we can do, just for a nice simple implementation, each time it's going to pick up a cheese, because we are running the Dutch version of the Pac-Man. On trigger, here, there you go. Here on trigger, when it's a collectible, it will add a score, but we also going to say controller rumble. I think it's in player ID, yes. Then we're going to make it a soft rumble, like 0.5, and keep in mind this is the duration is in seconds. So we want to have a short trigger basically. But if we are detecting when we are collecting a big one, then we're going to make a harder rumble. And when we picking up the power pellet, which basically transforms it into a Super Pac-Man, then we're going to rumble it for 1 second. I think this is still 0.5. All right, this is enough to work around with. Oh wait, yeah, I have some breakpoints. Oh yeah! And now, if I am now picking, oh yeah, now you feel it. It does work indeed. It just feels amazing now. But, okay. Before I'm going to bore you about how I'm playing Pac-Man, but now you can at least see that with some easy switching, we can just convert it to the controller, and I only added the inside the game where it needs to rumble, but that's it. All right, let's round it up. So at least we know that when using whatever controller on which platform, what to expect. But now you may be asked, why are you doing this? To make it production ready for Steam and itch.io. In the upcoming video, I will go to all kinds of different topics to make the game truly production ready. So in the next video, we're going to implement the hot swapping system for the input devices, including showing the correct button icons on screen. Oh, and remember, if the Meatcops channel hits 100 subs, I will do a live stream creating Pong. Until next time, bye!